session. Greeting of the day. In the previous classes, we are on the discussions of types of casting processes. In previously, we have seen about the solidification. Then we have seen about homogeneous, heterogeneous process, liquefations. In continuous with that, we have seen the solidification process of the pure metals, solidification process for the alloy systems. Those things we have seen. Then also we have seen about the types of other casting process than that of the sand casting process. We have seen about the die casting process. We have seen about the continuous casting, centrifugal casting process. Those things we have seen. In continuous with that, now we move to the investment casting process. It is one of the important type, and it is used in the from the earlier days. This die casting that we have seen recently they have invented, 100 years old, likewise we have seen. But here it is started very early. This is the initial method of the casting process. You see, it can provide a very thin and most complex features. It means we are going to design an interactive design objects we are going to do. A complex design object we are going to do. Not a simple casting process, not a box, a design, a jewelry, a shaft, a turbine wheels. Those things are complicated designs we are going to do in this investment casting. It is a very old method. It offers excellent surface finish. You see, in the sand casting process, the sand texture will fall on the material. It means the fall on the mold material. Therefore, the surface is somehow it is a rough surface. But now, here we are using the other method, using a wax pattern instead of using a sand pattern box. We are using a wax pattern. Therefore, it is very smoothly available. The product we are getting will be very smooth. It offers excellent dimensional accuracy. So their sand we have seen some allowances, distortion allowances, right? Those things we no need here. Okay, so the dimension accuracy will be maintained very properly in the investment casting process. It can be used to cast all metals and alloys. So here, multiple alloying system. In sand casting also it is possible. Here also it is possible to do all metals and alloys. So what we have seen, why we are coming to investment casting than that of the die casting process, we can go for all metals and alloys. In die casting process, if the temperature is increased, die may be melted. So some other die casting is a very fastest process. Those advantages is there, but even though some disadvantage also is there in the die casting. Okay. So similarly, we can go here for investment casting, all metals and alloys, good surface finish. It is very thin and complex features can be done. In die casting process, as per design, it comes. It simply it opens up. But here also very thin, most complex features can be done. Right. So how the all metals and alloys, how we are telling. So a table it is there. You see, in the die casting process, in the die casting and the investment casting. So other well-defined sand casting process are there. So this we can, for the comparison we can take. So the ductile iron, tool steel, stainless steel, aluminum, magnesium, copper, bronze, titanium, superalloys. So I have divided into some other multiple categories of alloy systems. In these alloy systems, see, this is the last one is the investment casting process. There are some few other difficulties which is involved there, which is not making here. Which is not making here. It is not made here. Okay, therefore it is not possible. It is not made here. It is not made here. It is not made here. So here it is not possible. Okay, therefore in this case is see, in the sand casting process, titanium alloys are not possible. So some other here, everything is possible. See, investment casting, ductile possible, tool steel possible, steel, stainless steel, aluminum, copper, titanium, superalloys, all are possible. So some every metals and alloys can be made by investment casting process. So it has advantages. So before going to understand the process, the steps involved in this investment casting, little bit we should know about how, from where this investment casting started. One by one we will see. You see, the principles can be tracked back in 5000 BCs, when the early man employed in this method to produce the tools. So what it is, you see, in the early days, for making war between the opponent parties, they used a tool to go to these moving objects. How they have prepared this? How they have prepared this spades to throw? Initially, in those days, there's no cutting tools, those and sharpening. Then nothing they have did. They used this method of investment casting. How they have did? You see, they have taken a wax pattern. This is a general idea. You should go for the steps. Procedure is there that it will follow. This is the general idea how this investment casting is oldest method that we are seeing. They have taken a wax and they have designed this like this shape I need, and then they have made. See, in this picture, I want to make a 3 object. This is 1. Okay, this is 1, and this is 2, and that side it is 3. Similarly, I have here also the riser is there. When I'm putting a molten metal inside, it comes and indicator is there. Okay, that is indicator. Now you see, the wax pattern is prepared in such a way it contains the hollow and the design. Now, when the hot metal is pouring inside, the wax will melt. We know this. Therefore, around the wax pattern, I am creating the sand molding box I have prepared. At center the wax is there. Here maybe it will be like this. So it is there. It will be, so 3 are there. That also similarly 3 guides are inside. Okay, so I am poured. And similarly you can see this point it is the indicator point. So after filling, it comes out. These things they have used it before in 5000 BC itself, they have used it before. So after this, when it is heated, when the sand is dry sand, wet sand to be fixed, and it should be heated at the same time, wax will comes out, it will dried out because it is heated already. Then after that, empty cavity is there on the sand. On the cavity, we are pouring. So wax pattern preparation, then the pouring, then the knockout. After pouring, it should be solidified. After solidifying, we are breaking. We are receiving the finished as designed object. Now what I am doing? I am cutting here. I am cutting here. I am cutting here. The 3 objects are ready. So this methodology they have followed in the previous earlier days. This method is called as investment casting process. It's very easy method. Wax, pattern ready, then the box, sand box preparation, drying, melting of the wax, creating the cavity, on the cavity, pouring the molten metal, solidifying, cutting. Okay. So the process was used for making an art casting process. As a few images I want to show you here. Such images, the wax pattern design has been made, the structures has been made, and then those has been sand molded and they are poured and created. So this we have used for the art casting also. The product for work purposes, any object we are preparing automobile parts, shafts, designs, whatever we are doing, some others also they have made, like art casting, some designs neatly design has been made. One more, art casting, a design which is made by using the bronze. A bronze has been melted and poured, and some superb art has been we are receiving. Some more examples I will show you. Some more examples. See, the dancing girl is one of the ancient statue which is made by our Indians, developed by the Indians. It was made around in 2500 BC in the Mohenjo-daro role in the Indus Valley civilizations. Now, likewise, the designs, attractive designs they can able to make. Where are we are using this? We are using this investment casting. Our first scientific use was in the year of 1897. Scientific use, before that there were and this art castings, designs that doesn't that they are used, but useful. This 1897 they are used for dentals, for tooth implantations. They have used this. We could have seen they will put some glaze in our mouth and they will take the pattern of the tooth, and then they will keep mold, cavity creation, pouring this. They will create artificial dental parts, and then again they will fix. This is all made up of investment casting. We have unknowingly we have seen this. By knowing and unknowingly we have come across this type of a casting process. The technology had great evolution in the United States during the Second World War. They are used more for war purposes. Okay, there was a great need of making the precious components. Precious components they have made, which are complex geometry. This is what I told in the first slide. Thin and complex geometry. Thin and complex geometry such as turbines, blades in the aircraft engines. Everything they have made. Few photos I have included for our easy understanding. And these are all made in the during the Second World War time for making of turbines and blades they have made. Now, in the development of 20th century, now recently what they have did in the recent times. You see, the development during the 20th century they have divided into this type of molds. The solid mold, or they are also called as black mold investment casting process, a plaster mold investment casting, mercast process, ceramic shell investment casting. So, I am dividing this investment casting process into such categories. Finally, we concentrate here in the ceramic shell investment casting. This contains 8 steps. This we have to know. Before going there, we should know what happened in the history. Then we should go there. Okay. So these are the solid mode, plaster mode, mercast process, or the other type of some other processes available in accordance with this investment casting. Now, in this class, we will see about the ceramic shell investment casting process. The name says ceramic shell investment casting. So we are going to use the ceramic mold. We are going to use the ceramic as a mold box. Okay. So the ceramic shell investment casting process. So the major steps involved in this ceramic shell investment casting process are the wax injection. As usual, we are preparing the cavity by using the wax, then the pattern assembly, then the shell building by using ceramic. So that is what the idea. And then after preparation, we have to dewaxing. This is interconnected here. The dewaxing process, then the pouring casting, solidification. After solidification, we have to knock out, breaking the shells and cut the parts which are not needed, and then finishing and secondary operations like annealing, heat treatments can be done. So we will see one by one. The first one, in this process I have taken a wax injection process. So we have to know what are the wax types are available. Those things also we should understand. The pattern wax is normally modified and blended with the other waxes and materials such as plastics, resins, fillers, antioxidants and dyes in order to improve the properties. Why we are adding the wax is fluidity. It can flow everywhere and it's easy to mold. But also the melting point, it easily in immediate it melts. Therefore, we should add some filler materials, resins to maintain somehow a hardened stages until it is created the design, complex designs. Therefore, we are adding waxes maybe 70% and resins of 20 to 60% and fillers of 20% and other additives for molding creations to withstand hardenabilities. We are adding few fillers there in the addition to the original wax. So there are various wax types are there in the industry that we are using to our investment casting process. They are the paraffin waxes, microcustody waxes, cannulate waxes, cornel waxes. So the various waxes we can able to see, we can able to list out also. So number one, the paraffin wax is the widely used. This is the widely used methods. For our case also we are using this one. It is a white or colorless soft solid derived from the petroleum. So this is what they have, from where they have taken petroleum products that consist of mixture of hydrocarbon molecules. So somehow you can see it is a pure white or colorless we can tell. Okay, it is nothing color out there. So other types are have given for 2 to 5 types. Microcrystalline wax, it is a type of wax produced by the de-oiling of the petroleum during the petroleum refining process. Some other wax we are creating for our investment casting processes. So such things other I have given the various wax we are using for our present in the industries. This wax and Fisher's waxes, other wax types are available. Now the common filler mix in the pattern, we have talked about 70% of waxes. Remaining 20% and 10% of fillers and resins we have to add. That we have to see here, the fillers. So common fillers mixed with the pattern waxes are spherical polystyrene, hollow carbons and spherical pattern of the thermosetting plastics. This they are adding to make somehow increasing the melting point. Somehow it can withstand some of the molding conditions. The fillers have a higher melting point. See, the fillers have higher melting point and are insoluble in the base wax. Hence, it contributes to reduce the solidification. Easy solidification reduces it will be. Therefore, we can use it easily. So, shrinkage and the other defects can be avoided in this concern. So now I am coming. Wax is prepared now. So out of this all steps, now the wax is ready. This wax is ready now. This process is over. Now we have to make the pattern assembly, shell building, dewaxing, casting. One by one we have to move ahead. Right? Now I am taking the pattern preparations I have to do. See, the pattern is prepared by injecting the molten wax along with the resins, fillers and into the metallic die. So it is also like a die casting process where the machine setup is used to create a pattern. So this is some of the wax injection methods and machine setup. Now we are going for the assembly. Very important method in this setup. Pattern assembly. How we are doing? You see, the hundreds of wax pattern are produced in a single session. Hundreds of wax are produced in a single session. So we are combining multiple waxes in a one single gate. We have types of gate we have studied in the first units somewhere. How we have kept the common gate system and we have attached a number of setups there. Likewise, here also hundreds of wax patterns are produced in a single sessions. Several such as patterns are joined together in a central tree. They are calling as a central tree here to achieve the economical status. It's known as a pattern assembly. How we are doing now? You see, as of now, for the case study, I have taken a preparation of a gulp head. This I am going to do in the upcoming 20 slides. I am planning the investment casting process to prepare a gulp head, okay, through a ceramic shell investment casting process. So for example, for the case study, I have taken this. Okay, so this we are going to prepare at the last. So for the hundreds of patterns, wax patterns are prepared all together with a single tree. See, hundreds or thousands of wax patterns are produced in a single session. We are assembling and pouring at a common tree. See, in this picture you can able to clearly see we are waxing these various pattern designs. This wax pattern design here. The wax pattern designs are assembled together in a single tree. What happens? All together it fills, all together pattern is ready, all together shell molding is ready, and all together you can pour, all together you can solidify, all together you can take out. One of the easiest method of pouring, solidifying. So we are first in this setup. First the waxing process has been done. Waxing injection has been done. Then the pattern assembly we are doing. This is one pattern. Golf head pattern. This is 1. This is 2. This is 3, 4, 5, 6, 7. So we are in this image we are creating a 7 golf head. Similarly thousands, similarly hundreds we can do. Okay. So now the wax injected, the pattern assembly is ready. 2 steps are over. See, next what we are doing, these setups are transferred to the slurry room. The tree are then transported to the slurry room. Where is the slurry room? The next stage after assembly, we have to pack the ceramic shell. I told you multiple times we have to dip because ceramic shell we are creating around the wax pattern. Then we are going to dewaxing process, and the cavity, the hole with respect to ceramic shell will be there. On the ceramic shell only we are going to pour. Okay, that we are preparing. So this patterns are already prepared. See, here it is available. Patterns are already prepared. Wax patterns are already prepared, and we are sending those things to the slurry room where we are going to coat a ceramic slurry. Slurry is nothing but a paste. Okay, multiple layer paste we have to do. In each layer, it may be 2 to mm increase. We need a strong ceramic shell, a thickness. Then only it can able to withstand this pouring hot molten metal, and then it can able to withstand. Therefore, we need to dip multiple times. For long time, if we are keeping on a ceramic wet slurry, it won't be. Therefore, we have to take, dry, keep, take, dry, keep. So multiple times, 5 to 6 times we have to do. So this is forward to the slurry room now after assembly is done. Pattern assembly is done. So now, next one, here we are moving. This wax injection, pattern assembly completed. Now we are going to the shell building process. Before going to the shell building process, we should know what this ceramic slurry will contain. The ingredients of ceramic slurry are, it may contain the refractory floors of powder 80% first. This refractory powders. Then the liquid binders to combine ceramics combination. We need some binding materials, the gums, such for example I am telling, such binders are needed here. Solid binders, liquid binders. So here we have taken 15 to 30, 5 to 10%. Total 80, 10, 10 we can take. Okay. So this they have given the list: zirconium silicate, fused silica, fused aluminum oxides. This all we have taken as a refractory powders up to 80%. Then we have, with respect to that, we are taking the liquid binders and the solid binders up to 10% and 80%, totally 100. So we have prepared such a ceramic slurry is now ready. It is a paste. It is a liquid paste. We have to dip, dry. This subsequent process to be made. Right. So now that one, there are various stages of slurry. In the slurry itself, there are various stages that we know now. What is the various stages? Dipping and drying, 5 to 6 stages. That is what they have given. First, dip slurry in a very fine texture that can easily get down into the details of the grooves and the engraving graphics. What they are telling, if it is a semi-solid, fluidity won't be there. If the fluidity is not there, it won't reach all the nook and corners of the complex design. So what we are doing? So I am planning to make a good fluidity slurry material in such a way this fluidity will flow everywhere, all the corners, and reaches all the complex designs. That is the first step, first layer. If the first layer is reached, pattern is there. You see, the pattern is here. Likewise, the pattern is there. So I have one design there. I want to dip this box here. I am dipping inside. It means the wax pattern is dipped inside. If it is dipped inside, the liquid fluidity, the fine slurry, it goes here, this corner, everywhere it goes, and it will be locked. The design has been captured by the slurry. So we will get. Now the second layer, the third layer, we can have a coarser slurry material because the first layer is already covered. The complex design has been inserted. The fluid has been went inside and captured the design. The outer design may be coarser. We are not bothering. So outer region for thickness, for the strong shell mold. That's it. Okay, so the second stage we are going. So second, the next slurry coatings. I told you 4 to 5 coatings to be done. Each coating will be 2 mm likewise. Okay. So next slurry coating is coarser. The next slurry coating is a coarser than the first dips. First dips. We have to dip 4 to 5 dips. We have to do. Then only it will become thicker and stronger. As it builds a thick shell, see what I told you is coming, as a thick shell around the wax tree. Around the wax tree. Now it is ready. So wax tree we have sent there from the building of assembly. We have sent to the slurry room. In the slurry room, we have did a first dipping, second dipping, third dipping. From the fine dipping to the coarse dipping, it will go. What stage by stage? 1, 2, 3. First one will be a fine dipping, coarser dipping, coarser dipping. So likewise, we can increase the thickness. We need the shell molds to be strong. That's it. But the fine details also to be filled. Therefore, the first layer is more fluidity, a fine. Then the second layer, third layer become a coarser. Next, the slurry has to dry between a successive dipping process. So I told you, first a fine, then it is dry. The second, it is coarse, and then it is dried. And then the third, it is coarser, and then it is to be dried. So each time we are dipping. This is dip 1. Dip 1. Here it is dip 2. Dip 3. It keeps on going up to 5 to 6 times. So in such a way we can able to make a thicker sections. The slurry has to be dried. See, it is to be dried between successive dippings, various dippings. I told you dip 1, dip 2, dip 3, up to dip 5, dip 6. Temperature and humidity have to be carefully controlled. That is okay. So now this up to this part is over. Now we are coming for the dewaxing process. Wax injected, assembled, then the shell molding is prepared around the wax pattern. Now the wax is not needed. We need the cavity. On the cavity we should pour. Right? It is a dewaxing process. It means nothing. We know this step. We are going to heat. In the heat, wax is going to come out. Simple. Right? Dewaxing process. The period to pouring the molten material into the ceramic, prior to the pouring, the wax inside the shell has to be drained out. Drained out completely, which is known as a dewaxing process that we are doing. So you are using a oven used for making the heating process of this assembled tree, assembled shell mold. In such a way, the dewaxing will happen, and the remaining part of the outer shell, the ceramic shell mold will be there. Dewaxing will be done, and the oven and the ceramic shell will be kept empty with the cavity. On the cavity, we can able to pour. Such way we can able to easily do. See, so this is the setup of autoclave oven, where we are keeping, and it will be heated, and it can be wax compensated recovery. We are taking out some setups of oven setup, oven circuits. Then, now very important. Now we came here. Now we came after this injection, dewaxing, shell molding, all dewaxing done. We will come to the casting process. Now it's very simple. Now what we are going to do here? Pouring, So pouring and solidification to be done here. We see, these are not easy only. The ceramic mold must be heated up before molten steel can be poured into them. What we are doing, we are keeping warmer the ceramic shell. We are just keeping warmer because the temperature gradient is there. Immediately it will solidify. Ceramic shell at room temperature, we are pouring the molten material at the 1700 degrees centigrade. It is in the room temperature. Therefore, the temperature gradient will be there between these two. If the temperature gradient is, what happens? The rapid solidification, progressive solidification process will happen. Therefore, to reduce the progressive solidification, we are making a warm temperature on the ceramic shell in such a way both solidifies slowly. Always the temperature exchange takes place from the molten metal to the ceramic shell quickly. In such a way solidification happens quickly. Therefore, cracks are chances. Progressive solidification may happen. Therefore, it may not reach all the complex design corners that we should avoid. Therefore, what I am doing, I am already pre-warming the ceramic shell mold. That's why I am keeping this shell cavity into the oven furnace and we are heated, just become warming, and then we have to pour now. Right. Now the actual casting process. What I am doing, here the setup is there. I am pouring from the ladle. I am taken the molten metal at 1700 degrees centigrade of steel and I am pouring into the ceramic shell mold. The cavity is there. Cavity is prepared by the waxes. Waxes, dewaxing process is done. Now the cavity is ready. We just pouring and solidifying. Steel is being poured from this crucible into the iron head mold. The mold cavity we are pouring and solidifying. What is the next step? It is to be solidified here. Pouring and solidification to be done. We should wait for a while then. We should not break immediately. Right? See, we are waiting now. After shell is filled with the liquid steel, it is a liquid, it should be converted into solid. It should be converted into solid. Right? It must be set aside to cool down. Now from the furnace, we have poured and we are keeping away from that and we are sitting for a while. Because it may take time to solidify to reach from the 1700 to come down to the room temperature. Okay? So we have to give a time for that. Right. Now, freshly poured ceramic shell generate a lot of ambient heat. So it generates here and the temperature gradient is there. So the area itself will become hot condition. Okay, that is what they are representing. Right, now the casting process is over. Now what we are doing here now, next one, the sixth step, we are going to knock out. It means the breaking. Because the product is inside, shell molding is not required, the product is needed. We are breaking the shell molding now. How we are breaking? We are using a motorized chisels. Motorized chisels are used to break the ceramic shell. Ceramic shells are not needed. We need the product only, not the ceramic shell. Okay. So, break the ceramic shell away from the cast product. This we need. This cast part we need. How we can able to break manually also. Manually or the motorized scissors. See here. Here the setups are there. The employee is keeping the pattern. It means the ceramic shell box which contains the product and doing the motorized chiseling hitting process they are doing. One flow is doing there. One more flow is manual heating process also done here. So such can be done and we can able to take the parts out. How the parts will be? Parts will be in continuous. We have already combined multiple hundreds and thousand parts. That is to be cutted now. You see. Right? So after doing this ceramic molding cutting process, there will be the part having a complex design or the corner parts inside here and there. What happens? This ceramic are already kept inside. It means already fixed inside. It should also be removed. By simple breaking process, manually it won't break. Therefore, what I am doing, I am using a sand blasting process. Here, the metal tray is sand blasted, forcefully keeping inside a furnace, like a furnace type sand blasting setup, and then I am rotating a sand, throwing a sand here, throughout there, and it will be rotated. So what happens? Throwing sand here fastly will erode the material, erode the ceramic shell is already coated or is already fixed on the part. So that also comes out. The freshly prepared is ready now. Now the cutoff. Now what I am doing? Multiple we have done. Pattern assembly we have done 4 to 5, 10 to 6, 1000, hundreds we have done. We need to cut now. The casting are cut at the gates, which leaves excess material on the gate areas. It needs to be polished, and again if needed we can do polishing. The part is ready now. We are doing a grinding machine. We are using a grinding setup to cut each and every parts. We have already 5 parts are assembled. We have seen in the pattern assembly. 5 parts are assembled. Each one is a one gulf head. Each gulf head has to be cut separately. Right, last one, the finishing and secondary operations. If needed, the casting are heat treated. If needed, normalizing, heat annealing, those treatment we need. For some applications to increase the property. Oh, those cases we are doing the heat treatment, normalizing treatment through the furnaces. Taking the product, cutting, we are putting inside. Product is ready. We can take out. After that, if needed, we can go for surface finishes. Surface finishes and polishing, painting, coating, those things we can able to do. See, here the heads are cleaned for final cosmetic preparation. What is the final cosmetic preparation? We are painting, and then in a neat way, varnishing, high polished, shining material we are converting. So such cases we can able to do here. So that is what here also. The final production steps involve adding of cosmetic paints. See, making of paints. Some designs we are making. Now the product is ready. After those 8 steps, now ceramic shell prepared investment casting product is ready. The gulf head. Finally, the product will be free from the defects, flaws, and visual appearance will be very smooth and polished surface, very neat, attractive. So there are advantage applications also we should see now. The size of the casting can vary from few grams of like dentals to the tooth from the 500 kg also, complex design also, few grams to 500 kg also it is possible to make. Excellent surface finish we are getting, not like a sand, the texture will not fall, therefore excellent finishes in order of 1.5 to 3.2 microns also possible. Close dimensions from 0.08, see, close diameter in sand casting, the allowances we are giving, distortion allowances we are giving, that things are not here. 0.08 to 0.13 mm is possible. Of close dimensional tolerance can be achieved. The typical minimum wall thickness, how much we can do? Minimum of 1.5 thickness can do. With a thinner section of 1 mm also possible. So these are some of the advantages. So very fine details. So that is what I told you. It can able to flow. This liquid metal can flow each and every complex designs. So fine details can also be produced, like castings, like jewelry castings are possible. Complex shapes are possible here. No negligible finishings operations are needed. No negligible finishing operations are needed. Because as it is product we are getting, gulfed as it is we are getting. We have done only cutting of the several hundred parts, and if needed we have done the normalizing part. That's it. We are not doing the distortion cutting process, allowances we are not cutting, surface finishings, that are not, if needed we are doing. But by the product, the sand casting product, riser have to be cutted, right? Pour basin somehow, this sprue have to be cutted, these things all you have to eliminate, that are not here. We are pouring in the ceramic mold box, it is ready and we are taking. Okay, that's it. So that wastage we can able to reduce here. So some applications, art casting, we are in the beginning itself we have seen some statues, art casting in the jewelries, in ancient applications they have used. Today applications of, but are found in the branches of various general and specialized engineering applications, everywhere it is in use. Relatively simple levers, scratches can be made, extremely complex designs, thin walled electronic changes, so thin to thick, light to heavy, weightless to high weight, or combination can be done by this investment casting process. So such examples of applications, images I would like to show you. The turbine blades are made by this investment casting process. So some of the various pump and valve components are produced by this investment casting process. So other medical implants, the tooth wearing are made by this investment casting process. See the jewelry components which are all made by this investment casting process. So you can see the complex interactive special designs are there. The molten metal should flow everywhere. The design should flow and reach the corner. The fluidity is needed. The molten metal to be at high temperature to reach that fluidity. If the fluidity is not there in the molten metal, obviously it solidifies before reaching that corner. We are pouring here, it goes here and it solidifies. It should not solidify here, it should go there, and then it reaches that corner, and then there it solidifies. It means we need more fluidity. Okay, so that are not easily done by this investment casting process. So all designs can be made. So some other automobile parts also, or the various parts we can able to make it have a look there. What are they available? Various automobile parts are the precision parts. All are possible in making by this investment casting processes. So limitations, a few are there. Even though this advantage, all metals, all alloy systems are doing some limitations. Production of a wax pattern makes the process costly. The wax pattern, I told you the various list of waxes. Wax pattern is somehow it is very costly. Making takes time. What we can say, it takes time. So that and all, it is costly. If time consume, employee consume, then obviously cost increases. Okay, the huge casting cannot be made. Huge, large type of casting. But in case of die casting process, or otherwise in the sand casting process, we can make large pipes. But here it is not possible. Some fixed amount of water, the slurry is there, the shell molding is there, that is possible. Maximum 500 kg in the previous things we have seen. Such possibles are done. Some of the limitations. Process is relatively very slow. Why it is very slow? Why it is very slow? Wax preparation, then 4 to 5 times dipping and shell preparation, ceramic shell preparation, and then dipping, waiting. Then only shell thickness increased. Then afterwards we are pouring, and then we are getting those products. So pouring, solidification, that is common, but this waiting time of wax preparation, these are heavy. So this makes the limitations. So these cases we can able to see. So alloy systems, what we are doing, the various alloy systems are all types of complexity we have seen. This images of ductile casting, carbon steels, tool steels, stainless steels, copper, titanium, superalloys. This all type of alloys can be done by this investment casting process. This table we have already seen. In the die casting process, here it is not possible. Here it is not possible. But how? In this investment casting process, this all type of alloys of ductile, tool, steel, stainless steel, aluminum, titanium, superalloys, all are possible here. Therefore, the investment casting process, we can do all type of assemblies. So the summary. In this process today we have seen about investment casting. In this investment casting we have seen about the ceramic shell investment casting process, and in this we have seen about some 8 steps very importantly. Okay, so the remaining part of this subject we'll see you in the next session. Thank you.